Hello everyone, welcome to video lecture on software architecture and design pattern. Today we are going to discuss third module, design pattern catalog. So now we are going to discuss the next structural design pattern is the flyweight design pattern. So this is the intention. So what is the purpose of flyweight design pattern or usage of in a architectural pattern? So intent or purpose is to use the flyweight design pattern is use the sharing to support large number of fine grained object efficiently. So whenever that a large number of fine grained object in a system, so there we are going to use this flyweight structural design pattern, so which is very helpful to communicate with all the small number of fine grained object in the subsystem or subclasses of the main system. So now we will move on to the next. There is no also name as this. Directly we will move on to the motivational example. So in some applications could benefit from the using object throughout their design. So but actually Navy implementation would prohibitively it is the very expensive. So for example, so object oriented document editor typically use the objects to represent the embedded like table, figures, lines, etc. So here for example, most document editor always implement have to the text formatting in case of editing facilities which are always to be modularized in some extent. So in that case, so we need to have that one how we are going to doing the wood. This is the flexibility it is required at the finest level of the application, or we can say it is a objects. So that is the major thing here, how you are going to edit without disturbing the actually entire classes a fine object. So where we need to add only one character, one alphabet. So that what we do like that is the character embedded. So that is the character embedded code then treated in uniformly. So here with respect to how they are drawn and formatted. The application could be extended to support actually new character sets, for example, without disturbing the other functionality. For example, we are writing the hello word, we should edit only the H, E, and the respective word should not disturb because that comes under the other objective format. So we will show that the following this diagram will have so the document editor can use the object to represent the particular characters. So here we will see the first about drawback of this one. What is the traditional method drawback of the approach? So we cannot use the object in each character in the document in design format. So the here character object, the row object, and the particular column is. So that is the word we have taken APPARENT. So in the traditional actually this entire will be affecting. So using the this, so even moderate or whatever a moderate size document may require hundreds or thousands of character object. In case of we have taken very simple character here, 7 to 8 characters, but if there is a an actual paragraph of editor, so that is the really disturbing to the entire systems. So this is the case, there is a big drawback, so which will consume a lot of memory, and in case of unacceptable it is a runtime overhead. So here the flyweight pattern describes how to shape the object to allow use their whatever the fine granularities, that is the small object, we can say the fine granularities is nothing but so without prohibitive the any we can say the cost. So here a flyweight is the structural design pattern which is a shared object can be used in multiple contexts simultaneously. the flyweight act as an independent object in the particular context. So this is the advantage of this flyweight structural design pattern. So actually it distinguished able to particularly the object whatever not shared. Flyweight also cannot make the assumptions but the context where they are operate. So here the very important concept of this flyweight design pattern is the key concept here is the distinction between intrinsic and one more is the extrinsic state. So we need to study or discuss about what is the meaning of intrinsic and extrinsic state. Intrinsic state is nothing but it is stored in the what we can say it is stored in the flyweight. It consists of information that is independent of the flyweight context, so thereby making it is easily shareable. Similarly, extrinsic state depends on and varies with the flyweight context, and therefore we cannot be shared in the extrinsic state whatever the character. So that is the thing. Object, the client object are also responsible for the passing this passing extrinsic state to the flyweight whenever it is need it. So we will see that this the description about distinct vessel instead of the object. So here that we have taken the two state, intrinsic and extrinsic state. So this is the shareable and non-shareable. So strictly we can say intrinsic state in the flyweight design part is shareable, and extrinsic in the flyweight structural design part is non-shareable. Non-shareable means that data will not be shareable. Similarly, this is the comes under that one a diagrammatical representation what we have seen in the previous diagram. So the entire column first we are going to divide into the row 1, row 2, row like that. So in one row there we have seen that in the previous APPARE apparent that character will be coming into the particular row. So like that this will be going to do. So suppose that again this again one more row will have hello world, again one more row will have hello hi everyone. So again one more row will have hello all the software architecture subject who are listening, so welcome them. So like that again if you have one more column, in that column again that is again will be divided into, and each number of row again is a character. So here one concept we need to know, for example a document editor can create a flyweight for each letter of the alphabet, that we should remember that one. Each flyweight stores that we can say that character code but is coordinating position to the what is the topographic style can be determined from the text layout algorithm. We say that formatting commands in effect wherever the character appears. So that is the character code intrinsic state. We have told about while other information is extrinsic and some information is extrinsic and other information may be intrinsic. Logically there is an object for every occurrence of a given character in the document. So this is the very simple way we need to understand this flyweight design pattern. Logically we say that object is occurrence of a given character in the document. Physically we say that, so however there is a one shared flyweight object per character, and it appears in different context in the document structure. So each here occurrence of particular character object refers to the same instance in the shared pool flyweight. So that we need to think about what is a pool flyweight things that we will study. What is the pool flyweight occurrence of the apparent what is the particular character here A, P, P, A, R, N, T, where we can keep that is the what is we can call it as the pool flyweight. So this is the comes the flyweight pool. Okay, this is very simple way to understand here. We have divided actually the one column, that entire column will have this particular character. Again row wise we have divided row 1, row 2, row 3, row 4. Okay, so in this row 2 assume that we have this character A, P, B, A. So this A, P, B, A, we have a one certain flyweight pool. So in this flyweight pool whatever the character to the whatever the characters are available in the this row which are available, we are taking from the flyweight pool, which are readily available here: A, B, C, D, E, F, G, H, I, J, K up to Z. Okay, so this row we will have this A. So A is taken from this C, from the direction arrow mark is connected here, from here to A. Similarly, P, next word is P. We have taken from this, what is that one? Another. Similarly, again P is the same character. Again we have repeated twice. That is called as a flyweight beauty of this structural design pattern, flyweight design pattern. We no need to have one more again. So because P twice repeated, so we are taking same row in the connected to the only one character. We are taking this. Similarly, we have to take this APP. Again, A will be repeated for the same character. A R again one times, R E again this is the one times, R E, and the next N and T. So whatever the character, this is the one row we are saying that. For example, if I have written, or we have taken the in the document, it is the hi, hello everyone. So H I will be taken hi, H E will be already is there here, E L L O. So hi, hello everyone, welcome to this after architecture region. If there is a word, so the number of times will be taking into the flyweight more. So that is the we have taken this refined grained object granularities, that we have taken that word. So here the class structure for those object is the shown whatever next, that glyph class, what we can glyphs abstract class for a graphical object for some of the which may be flyweight. For example, draw here, draw the intersect and know how the context the glyph is in before can do their job. So here actually the class we are going to take class structure of the object whatever is shown in the next. Glyph is a abstract class for graphical object. Okay, some of which may be a flyweight. We will take in next diagram. So their operation always that may be depending on extrinsic state have to be passed to them as a parameter. That is the thing here we need to count. Another, for example, draw. We need to draw and intersect with intersect must know which context or glyph in before they can do their jobs, that we need to. Actually here a flyweight representing a letter A, so only stores the corresponding character code. It doesn't need to store the actually its location or the which location. A is the in a full zeroth location and not required. It doesn't require for the location and the font. Actually client supply the context dependent information is always what the flyweight need to draw itself. For example, a row glyph, we had that in the row glyph knows that where its children should have themselves, so that they are what is that one, tiled horizontally. We can say that it's tiled vertically, horizontally. So that's what we can passing that child location in the draw request. Whenever that drawing request, that we need to take it. So this the, so here this is the diagrammatical representation of a glyph classes. So we told that some of them may be the flyweight, or some of here row or character. We have taken the character subclasses. Glyph is the main abstract class, and followed by row, character, and column is the subclasses of this glyph classes. So it may be we can take a bit, maybe a flyweight pool or design. So here the glyph class will abstract will call that one draw. Operation is the draw context. Okay, intersecting point or any context wise. Character, draw the context, intersect the point and context, character C. Similarly here column will have that draw the, again draw context, so intersect point and context of this one. Again here the children, which will be because this is the main abstract class. But here we need to think about the entire diagram. One thing is we have to, because what is the number of different character object is far less than the number of character in the document. So this is we need to count here. Number of character object is far less than the number of character in the document. So we had seen in the previous document editor, for example, apparent. So whatever that character it is considered as an object, which is always less than the number of character in the document, because document will have that certain letter or character, but this pool will have the less number of character, but because that character is repeated, because that communication has been taken into the place. So that is the thing of this flyweight architecture or structural design pattern. Similarly, actually the total number of the object is substantially less than the whatever the our Navy implementation use, that is the flyweight full we have taken. So a document in which all the character appear in the same font, obviously point, and here client also doesn't worry about the location and font of the particular character appeared in the row wise or column wise, or particularly in the pool. So here color, whatever the allocation of 100 characters. So roughly we can, the ASCII character set will be taken into the regardless of the actual documentation length. So this is the thing is, so whichever the document no more than 10 different font color combination, because already with the ASCII character set will be taken. So main thing here, an object abstraction thus becomes practical for all the individual characters. So this is the again representing of the flyweight. We have taken glyph. The class structure of this object is the we can taken it as a glyphs abstract class for a graphical object, some of which may be the flyweight here, some of which may be the flyweight design pattern. So now we will move on to the next our template part, sections of the templates and the architectural design pattern, applicability or applications of this flyweight design pattern. So the flyweight patterns effectiveness depends heavily on how and where it's used, that we need to consider. So apply the flyweight pattern when all of the following are true. We had here certain conditions. Whenever applying this flyweight design pattern, so this all should become true, then we say that this is the we can say that we can apply this flyweight pattern is suitable for the particular design problems. One is an application use a large number of objects, that obviously it should true, otherwise we never use this architecture design pattern. Whenever having any applications or a subsystem, for example, we had a simple library management. So there are a lot of applications will have the large number of objects, add, remove, and many classes and many subclasses, under that many subclass or sub object. So or we can say the compiler sub compiler system, that will have also large number of objects will be coming. So it depends, we are not about sure about that one. So any system will have a more number of class, more number of subclass, then followed by more number of object. So in application, that such applications use a large number of objects, so we can use this flyweight design pattern. So this becomes true, then we need to agree with this statement. So another one is the storage cost. Storage costs are high because of their sheer quantity of the object. Yes, obviously because of large number of object will be there, obviously the real storage will be become high, then we should agree with because this statement should be true when we apply the uh, uh, flyweight design pattern whenever it's applicable. So most, third one is the most object state can be made extrinsic. So we had defined that one, extrinsic is the non-seriable. So that we have to make it properly here, but most object state can be made extrinsic. In case of non that is the extrinsic case, non shareable, then our cost or the sharing whatever that cost of the storage cost will be coming to the low level. So because quantity of the object will be coming into the matter, so more here most object can be made extrinsic. So in the extrinsic case we will have, because the non shareable, that directly we can communicate to the fine grained object because non shareable is the better case. It should be when we apply this one, so this should becomes a true cases required. And many groups of objects may be replaced by relatively few shared objects once the extrinsic state is removed. So this we should stick on to that one. So whenever many group of objects may be replaced, for example in the library management or any compiler subsystem, if you are removing get token generated what a bytecode or stream code in node streams, so we what we need to do it that it depends on replaced by relatively few shared object once the extrinsic state is removed, because which is non shareable, then we should be always replaced by the all the shared object. So that is also one of the point we need to require. And one more point it is there, that is the application always here it doesn't depend on object identity, since here private object so may be shared. Identity test will return true for conceptually distinct object. So when we come to this part, applications, any applications, for example, any we are taking a compiler subsystem design or compiler system or a simple library management or any organization of hierarchy. If you take that one, so application doesn't depend on object identity. So any applications, for example, a library management system, so it is not dependent on the identity of the add book, remove book, or whatever that is, issue the book, whatever delete the this one, whatever that one. So that is not required, because that is entirely different. So application it doesn't depend on the object identity, because that object we can always anytime remove or add the or whatever that we can do it. Since private objects may be shared, or the sum of the private object may be shared into the particular part, and identity, so identity test will return true for conceptual distinct object. If there is a more number of fine grain object will be there, so there are many object will be distinct. For example, if you consider in the compiler design part, so generate tokens, parser part, or get tokens, so whatever we are taking into that part, so that all will be particularly all that will be the one of the different part that we say that conceptually, so true for we say that true for conceptually distinct object. So identity test will return true for this applicability. So this is the what we say that applications, so applications of applicability of the flyweight design pattern. So how that one, so the flyweight pattern effectiveness is depends heavily on, we told that how, on how and where it's used, in what way it is used. So apply while applying this flyweight structural design pattern, so we should have that one when all the following are following points, we can say the following consideration are should be true. So then after this applicability is next coming to we are going to the structural part. So next actually structural part of this flyweight design patterns, that is we can say flyweight factory will be considering, that is the flyweight we are saying that is the flyweight factory. So whatever that one flyweight factory, we are going to take it and how that it is going to implement it. We'll have that we can see in the next videos.